Hello, this is a demonstration video for Magic Strap Connect to microcontroller in order to use for Internet of Things or IoT. So, as you can see, this is a Magic Strap chip on the PCB, which is I2C interface. You can see have the 4-pin connector, which is consists of SCL, which is clock, SDA, power and ground, and this chip will running on 3.2 volt, and connector will connect to microcontroller. I'll show you next. So, EPC number, reading by microcontroller. Basically, EPC is longer than this, so we only use for 5 set on the beginning of this EPC for this number. And I was naming alias for this RFID or this unit as a magic number 1. The data will show here: temperature 27 Celsius, humidity 41%, and battery power 8 volt, latitude, longitude, which is reading by GPS behind the LCD screen here that you can see behind that antenna, and the sensor, which is a blue color. You will see later on to the demo board. This is considered as one node with antenna and the EPC attached to. So we'll try to demo how to send the data, and you can see the demo right here. See? Demo board, you will see the call, or we call the magic one as the alias, and also this temperature data and humidity 40% and power off the board that you saw earlier. Okay, right here, just want to show you, as I can explain you easier, what Magic Strap RFID from Murata can connect to microcontroller. And let me explain. So what sensor we use right here. So this is a blue one here, square, humidity and temperature sensor, the HT11. So all in one package, only 3 wire, power, ground and data. And see behind here is a transmitter from Radiometric, will transmit all the data, audio that you can hear in the background. That's a package. Well, it's easy how to explain that you hear the package as sound in one shot. Consider that packet is like a one baseball. So we throw the ball to the receiver, and you can see the receiver earlier. So the receiver will receive the package and feed that data to the internet. I'll show you the display on the internet later on. So, see how to explain here the display. Normally when you use on the field, you might not need to have a display, but this is show how you can have a display for application. Many of the application you can use. In the memory, RFID tag over here. So we're reading. Basically, the CPU will looping, or we can call pulling the data, reading from the sensor, and store RFID to the user memory. So we treat user memory here as a one extra memory with I2C interface. Why we have to use this one? Because RFID you can access without the CPU working. When sometimes you just program to the memory. So memory, you can store the memory in RFID, and then you can use RFID reader to access to the memory and reading EPC code, right? So let me turn on the power here. So you can see Magic Strap demo, battery power, CPU power, EPC code, and all the data all we need. And then when we power, we need to wait for the GPS. So GPS lock. And then you can see latitude, longitude, which is in this position. And remember this number, latitude, longitude, will represent, and this number will send data to the receiver. Okay, here the unit earlier. Here's a unit earlier, as you can see here. Let me focus a little bit. Magic number 2, 27, and humidity swing between 40 and 41%. And I'm gonna place the butt over here to send the data. We'll take a look at the receiver station, and I send the packet. You can hear the sound. Oop, see? Magic 2, EPC number, temperature 20%, 27, sorry. Humidity 41%, and power 8 volt battery power. So you can know what on the node Magic 2, what is the status will be like at open ground. Then this is will be that's it for this node. Next, I'm gonna show you how to see on the memory, as we use the benefit of Murata RFID tag. So this will be easy to explain with a demo board for RFID reader, which I got from the AS, which is called Austrian Semiconductor. Design this board for sale. It's very cheap one, and we plug in the low power antenna, and we press right next to the RFID tag. It's still connect to the CPU, so it means CPU will still reading the data and store, pulling, keeping, and saving into RFID tag here. Okay. Next, I'm going to show you the computer screen of RFID reader program. Okay, here's a reading program for AS399. Basically, it's a 3992. It's a demo board for RFID reader. This is a low-cost RFID reader. So I'm going to start scanning to reading. Oop. So, see this one? B9 F4 334455. I'm going to show you back to. So right here, you can see the number, EPC code the same. So remember this number, 26 Celsius and humidity 41%. Battery power 8 volt. We're not storing the battery power to the EPC, on the memory tag. So user memory is the address 6000. According to the data sheet, we're gonna use only 2 bytes for one value for temperature and another 2 bytes for humidity. So see the scan reading still scanning, so I need to stop, then I can access to the memory, user memory. Okay, and tag association, blip, sorry, wrong one. Advanced setting, and then as you can see right here, EPC number, reader ID, and manufacturing of the chip is NXP, and model number, well, we don't care about it right now. And here the most important part. So basically on the memory they have 1 2 3 4 user, tag ID, EPC. So we go EPC. It should read the EPC. Oops, sorry. See here, B9F43344. Then we're gonna take a look at user memory, which we talking earlier on why we started here. Okay, 6001. We use these two numbers. You see the rest of them is 0 because we don't store anything. The default on the memory is 0. So 1A and 29. Okay, 1A is a hexamal. So I'm gonna show you how to convert. We'll go to computer, calculator, which is have the feature to convert hexamal and decimal. So first we clear. So that is 1A, right? We press 1 and number A on the keyboard. See, you get 1A here. That's a hexamal right there. And then I'm gonna click back to decimal, which is normally we understand on decimal number. See, 26, same as the temperature, 26 Celsius, right? So it means we got the correct number to starting in the user memory. Okay, let's clear this one. We'll go back to the other one. Let's see here, 29. 29, same thing, it's a hexamal. So we go back here, we change to hexamal. So that one, 29, right? We click 29 right here. And then we convert back to decimal. So we'll see humanity, how many percent? 41. See? Right there. So what does it mean? It means this tag will have the data of the temperature and humidity all the time with no barrier. Even the microcontroller is turned off. The data is right here, but how do you access it? You access by RFID reader. In many ways, this is application advantage application for RFID or Murata RFID Tag Magic Strap. So basically, this is a feature that you can use for many applications, such as security. Normally, you put the chip to notebook, so to protect somebody will hijack the shipment on the way from manufacturing to the retail store, and the retail store can reactivate by program this without turning it on, right? Without turning on the power. So it means someone who stole the notebook, you cannot read the data because it's no activating code yet. Then, well, this is what explain everything. Well, we use the memory. Okay? But normally, access to user memory, some RFID reader might not be able to access this feature. Some of them, but we can choose between user memory or change the EPC code. So this is just give the idea. It's not that difficult to change the EPC code from microcontroller VIA or connect to I2C interface. Like you see it earlier, we access to the memory, user memory, and change. See, 8 bit equal 1 byte. So this is 2 byte, and we can use 4 byte for we can change EPC code. So to store the temperature and humidity sensor. So we can have more sensor you want, and you can use here. So wherever you scan, you can see right there. You don't need to go back inside for the memory. It's like a long way to go for some RFID reader, right? So it depends on programmer or application you requirement, right? Okay, here the good part. I'm gonna show you how to access. Basically, during what we're doing here, the microcontroller will feed the data to internet. Create the web page. It's just a simple one to show you. Right here. So see, Murata Magic Strap RFID I2C communication Murata chip Internet of Things, and I can show here the tag number 1, number 2, number 4. So we ID this one as number 2, and this is number 4, and then scrolling down, and you can see this is a map. Of this tag. So we see the tag here. Remember, this one is internet browser. So this is address. I put at here project.rfidthailand.org. Then, so this is a Google map what we're using, and we overlay them with the data what we need. So, and this is a real position. So we go here, zoom out, zoom out, zoom out. Oh, this is Bangkok, right? And then we zoom in, zoom in. So this is showing on this position, right? Same thing what the Google map does. And then we'll click the mouse here. Bling. See? We got here 26 Celsius. And what time? See, we have a time here. Date, time, humidity, how many percent? Right, EPC code on the internet, and power. So we got all the data we need. So we got plenty of the space so we can kill this comment, and we can put more sensor. We can put more sensor, soil sensor, pH sensor, water level, tide level, whatever you need. Yeah, we got the data here on the internet. See, zoom out, so you know where it is. And because it's a web browser, you can search on everywhere, even iPad, iPhone, right? Thailand, right there. And what else you get the data and you can use? See, right here. You can plot the map on the graph, and you can see how the different changing. And it changed 7 days. So you can see empty because I didn't turn it on. So normally we have to do data log. Well, that's about it. So this video created for Ascentech Thailand, and myself, created by Nimit Ongyim. So okay, go back here. Also, we can go to here, Google Map. Same thing, right there. Thank you for watching.